Good day everybody. I am Dr. Gitanjali Mahamamkar and let us begin with the second chapter in this lecture series, that is number system conversion. In this lecture we are going to study about the conversion of decimal number in a decimal number system to binary, octal or hexadecimal number. Now to convert a decimal number to any other number system with base r, like suppose we want to convert the decimal number to a binary number system, then its base is 2. So we all know that base of binary number system is 2. Therefore in this case r is 2. This is the number system and r is the base. Okay, so if we have base r, then divide the integer part of the number. Means suppose the number to be converted in binary is 19.625. Now here 19 is the number integer part and this is 0.625 is the fractional part. Then divide the integer part of the number by the base r, that is 2, and multiply its fractional part by 2, that is the base r. Okay, so let us begin. So if I want to convert 19.625 into binary, I will first divide the integer part of the number by 2. Now here this is the dividend, this is the divisor. What will be the quotient in this case? The quotient will be 9 is 18. So remainder is, we have to note down each time the remainder. Here the remainder is 1. Again divide the quotient that we get by base r, that is 2. What we get is 2 4s are 8. Remainder again is 1. Again divide this quotient that we get by 2. What you get is 2 2s are 4. Remainder is 0. Again you divide the quotient that you get by the base r. 2 1s are 2. Remainder is 0. Again divide the quotient that you get 2. You get 2 0. Remainder is 1. Once you get the quotient as 0, stop over here and read the remainders that you have got from bottom to top. Okay, what you get is 1 0 0 1 1. Now this is, here the bottommost remainder that you get is the MSB and the topmost remainder that you get is the LSB of the binary form of the integer part of this number that you want to convert into binary. Okay, now what will be the fractional part? Fractional part is 0.625. You have to multiply its fractional part by the base r. So 0.625 into 2 is what? What you get is 1.250. Now what you do is take again the integer part, note it down over here, and whatever fractional part is remaining, that is 0.250, go on continuously multiplying it by the base r. What you get over here is 0.5. So here again the integer part that you get, note it down. Again multiply the fractional part by 2. What you get is 1.0. Again take the integer part, note it down. Now once you get the fractional part to be 0 or closer to 0, stop doing this. Take the integer parts that you have got till now and include it into your numbers binary form. Now this is 19.625 in binary form. Okay, so this is how you convert a decimal number 19.625 into binary 10011.101. So similar method you have to follow when you want to convert a decimal number into its equivalent octal or hexadecimal number. So what we will do is, again, to convert a decimal number to any other number system. Now here the number system is octal. If you want to convert it into octal, what is its base? Its base is 8, right? So what we will do again, if I want to convert the decimal number 19.625 again into its octal form, again I will divide 19 by the base r, that is 8. Now here in this case, what is it? You have to divide the number integer part by the base r, that is 8. So what you get is 8 2s are 16. Remainder here is 3. Divide the quotient that you get by 8, you get 0. Remainder is 2. Once you get the quotient 0, read it in the read it from bottom to top, where this will be bottommost number or digit you get is the MSB and this is the LSB. So integer form 19 in decimal can be written as 23 in octal. Okay, and now take the fractional part, that is 0.625, and multiply its fractional part by r. Here r is what? 8. So multiply this with 8. Okay, what you get is 5.0, right? Now take the integer part, that is 5. The fractional part has already become 0, so we will stop over here, and what you get is 23.5 in octal. So 19.625 in decimal can be written as 23.8 in octal. This was its binary form. This is its octal form. Now similarly, if I want to convert it into hexadecimal, then we all know that hexadecimal's base is 16. So I will have to divide the integer part of the number 19.625. Integer part is 19. I divide it by 16. What I get is 16 ones are 16. Remainder here is 3. 1 is the quotient. Now divide 1 by 16. I get 0. Remainder is 1. Once I get the quotient 0, I will stop and I will read the remainders from bottom to top. The bottommost is the MSB, topmost is the LSB, and the number integer part 19 in decimal can be written as 13 in hexadecimal, and I again take the fractional part, multiply it with the base r, that is 16. What I get is 10.0. You can try and multiply this. 10.0. I take the integer part, here integer part 10. So in hexadecimal, if you remember, 10 is written as A, right? So what I will do is 13.A, because if you remember, in hexadecimal the digits are 0 to 9, and 10, 11, 12, 13 and 14, 15 are written as A, B, C, D, E, F respectively. You can refer the earlier lectures in which I have discussed about hexadecimal number system. So 13.A is 19.625 in decimal, is 13.A in hexadecimal. Okay, so this is how we can convert a decimal number to binary number system or octal number system and hexadecimal number system. The method is same. You have to take the integer part, go on dividing it by the base r until you get the quotient 0, and whatever remainders you get, you read it from bottom to top, form the integer part. If you have a fractional part in the number, you have to take the fractional part separately, go on multiplying it with 2, separate out, just extract the integers part and go on multiplying the fractional part further with the base until you get the fractional part 0 or nearer to 0, and write down the fractional part integers of the fractional part multiplied by the base. Okay, and write it down over here. That will be your number in the other number system, decimal number in the other number system. You have to follow it for binary, octal or hexadecimal. So that is all for decimal to any other number system coverage. Now if I want to convert binary to decimal, octal to decimal or hexadecimal to decimal, again the method is same, means common. And what is that? Let us see. Now let us see what I have to do if I have to convert any other number system to decimal number system. Here, if the number has xn minus 1 up to x0 places, point x minus 1, x minus 2 up to x minus n. This is the form of the number. Like if, and this is the base r. Okay. Now if I have a binary number, let us say with say for example 100111, this is the binary number, then this place is b0, this place is b1, b2 up to b3, b4, b5. Okay. Now if I have 0.11, then that would be point b minus 1, b minus 2 and so on, right? Now this base is 2 for binary number. Okay, what I will do is, if I want to convert a binary number to decimal number, then I will have to multiply each of this bit or binary digit with its corresponding weight and sum it up, right? Similarly, if I have a number 100,111.11, then the corresponding weights would be, here this would be 2 raised to 0, this is 2 raised to 1, this is 2 raised to 2, this 2 raised to 3, this 2 raised to 4 and this 2 raised to 5, right? The weight of this number digit is 2 raised to minus 1 and weight of this bit is 2 raised to minus 2. So I will have to multiply each bit with its corresponding weight and add it up, right? This is the binary point. Okay. Now to convert this binary number to decimal, I multiply it as 1 into 2 raised to 5 plus 0 into 2 raised to 4 plus 0 into 2 raised to 3 plus 1 into 2 raised to 2 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0 plus 1 into 2 raised to minus 1 plus 1 into 2 raised to minus 2. Right? So this is the method to convert 100,111.11 to its decimal form. Right? So as we all know, what is 2 raised to 5? It is nothing but 32, if I am not wrong. Yes, 8 to the 16 to the 32, yeah. So 1 into 32 is 32 plus 0 plus 0 plus 4 plus 2 plus 1 plus 1 into 1 by 2 plus 1 into 1 by 4. So this is 39 point, this is point plus 39 plus 0.5 plus 0.25. So that is 39.75. Okay. So this is in decimal. This is how we convert a binary number to its equivalent decimal number. What you have to do is multiply each of the digit with its corresponding weight. How do you assign the corresponding weight? We have seen in earlier lecture that if the base is r, then the corresponding weight is in terms of r raised to 0, r raised to 1, r raised to 2, etc. Right? And after the point, like if it is a binary number, then after the binary point on the right hand side, we have r raised to -1, r raised to -2 as the weights of the bits after the binary point, and we multiply it accordingly. Right? Now if I want to convert octal number to decimal, then let us take octal number 601. If I want to convert this to decimal, then here its weight is 8 raised to 0, its weight is 8 raised to 1, and the weight of this digit is 8 raised to 2. Right? So what I will do is I will multiply 6 into 8 raised to 2 plus 0 into 8 raised to 1 plus 1 into 8 raised to 0. I will get the corresponding number in decimal. So 6 into, so what I have to do is 6 into 8 raised to 2 is 64, right? So that is 64 plus I have 0 plus 1. So this is 384 plus 1, that is 385. Okay, in decimal. So this is how I convert 601 in octal to 385 in decimal. Now if I take a hexadecimal number, take for example BFF point C. This is hexadecimal point C. Hexadecimal. Okay. Now, as you all know, what is the equivalent weight of this place? It is 16.0. This is 16 raised to 0, 16 raised to 1, and this is 16 raised to 2. This will be 16 raised to -1. Okay, but how to multiply b with this? So you have to convert the equivalent number, like as we have told you already that b is actually a representation of 11, f is equivalent to 15, c is equivalent to 12. Like instead of 10 we write a, 11 we write b, 12 we write c. Similarly, instead of 15 we write f in hexadecimal, right? So what you do is multiply 11 by the corresponding weight plus f is what? 15 by its corresponding weight. Here again 15 by its corresponding weight. Then after the hexadecimal point you have c. So c is what? 12. So 12 into the corresponding weight. Okay. So So what you do over here is for BFF, right? This is 256. So 11 into 256 plus 15 into 16 plus 15 into 1 plus 12 into 1 by 16, right? So this is 11 into 256 is 2816 plus 15 into 16 is 240 plus 15 plus 12 into, you have 16's fractional part, this is 6 to 5. So what you get in total is 3071.75 in hexadecimal. This is the decimal part, decimal form of hexadecimal number BFF point C. So it is quite simple. I hope you have understood what I have done. I haven't taken the example of octal number fractional part. So let me take another octal number to explain it. Suppose the octal number is 1070.02 and I have to convert it into decimal. Then what I will do, I will multiply each of the digit, octal digit with its corresponding weight. Like here the corresponding weight is 0, 1, 2, 3. 8 raised to 3 plus 0 into 8 raised to 2 plus 7 into 8 raised to 1 plus 0 into 8 raised to 0. Okay, and the fractional part after octal point, what you do is 0 into 8 raised to minus 1 plus 2 into 8 raised to minus 2, right? Go on adding it. 8 raised to this is 8 raised to 3, right? So 8 raised to 3, if I want to do, what I will do is 5 and 2. So 1 into 5 and 2 plus 0 plus 7 8 is 56 plus again 0 plus 1 by 8 is 0.125 plus 2 into 8 1 by 8 square, that is 2 into 0.015625. Okay, so that will give me, the sum will be 568 point, it is 03125. Okay, so this is the decimal form of octal number 1070.02. Okay, so this is how we can convert a number in any number system to decimal number system. Okay, that's all for today. In today's lecture we've seen how to convert a decimal number to any other number system, that is binary, octal or hexadecimal, and vice versa. Thank you.